Good morning, Algebra. It's Monday. Let's do some algebra. It's going to be awesome, of course, because what's better than doing some math on a Monday? Okay. We're going to go back and review something so that we can take it a little bit further. We're going to review solving quadratic equations by taking the square root of both sides. Okay. So we know that we can take the square root of both sides if both sides are perfect squares, right? That makes sense. So let's take a look at this one. I look at this x squared plus 10x plus 25, and I see, hopefully you see, a perfect trinomial square. Hopefully by now you can see that. So I see the first term is a perfect square. The last term is a perfect square. And if I check it, right, I can say, oh, the square root of x squared is x. The square root of 25 is 5. I multiply those two together and I double it. Well, good job, I got that middle term. So it is a perfect trinomial square, which means that I can factor it to a binomial squared. All right, if you're still wondering about this, then please contact me because we need to check in on it and make sure you know it. All right, what that means is that I can take the square root of both sides, right? I can do this in my head. I don't need to write it, but you can write it certainly if you want to show it. And so the square root of anything squared is itself, because x plus 5 times x plus 5 equals x plus 5 squared. And then we're going to remember, please remember to do this plus or minus thing. This is one of the key learnings here, the key things that you need to remember to do these kind of problems. So we have x plus 5 equals plus or minus 3. So x plus 5 equals positive 3, x plus 5 equals negative 3, all right? And so then I can take that, and you can write it out, and I wrote it out on my examples, but you don't need to. You can take x plus 5 equals 3, minus 5 equals x equals negative 2. And I could write out, if I want to, x plus 5 equals negative 3, minus 5 from both sides, and I get x equals negative 8. Okay, great. So what if we have that the perfect trinomial square equals a number that is not a perfect square, right? So I put 11 in here. So what if it doesn't equal a perfect square? So I did the same thing. I factored both sides. I factored the perfect trinomial square to a binomial squared equals 11. I take the square root of both sides here, right? This is my job, take the square root of both sides. And so I did that, and I got x plus 5 equals, again, we've got this plus or minus here, which is really important. Plus or minus, or positive or negative, square root of 11. And I can just leave it like that right now, square root of 11. Then I'm going to subtract 5 from both sides because the goal is to get x alone. What does x equal? And of course, if it was a normal number, not square root of 11, I would subtract 5 from both sides. And I'm going to tuck it in front. I'm going to put it in front of that square root of 11, okay? So tuck it in front. So minus 5, tuck it in front. So I've got x equals negative 5 plus or minus the square root of 11. Now you can take this and put it into your calculator because I do want you to see that it equals a number. Like if you needed to put this on the x-axis, you can see that we would put it at between negative 1 and negative 2 and between negative 8 and negative 9. All right, so I'm going to take my calculator. I use a little negative button at the bottom, negative 5. I'll do plus first, plus. And then I'm going to do second square root, which is the x squared sign, 11, close parentheses, equals, and I got negative 1.68. All right, so hopefully you can put that in your calculator. So you can clear it and do negative 5 minus the square root of 11, and I get negative 8.3166. I rounded it to the 100th place. All right. So this is the basic concept here today, is taking the square root of both sides, and especially learning to do it where we've got a number that is not a perfect square, all right? In addition to this, though, let's take a look at this problem. Like, what if I didn't know, what if I didn't have a complete perfect trinomial square, but I needed to make one. So we're going to take a look at this. If I have, let's say I'm given this x squared plus 10x plus what goes in the box, right? Plus c, really. And so what we find out, and on your paper it says this, it'll say 10x, or x squared plus 10x plus c. And what we know is that c is going to equal half of the middle term, so 10 over 2 squared. So we know that c equals 25 here. So the whole perfect trinomial square is x squared plus 10x plus, take the middle term, or not the middle term, sorry, the middle coefficient, just that 10, just the b, divide by 2, which is the same as multiplying by 1/2, and square it. And so this in parentheses, PEMDAS, right, equals 5 squared plus 25. Okay? I've given you several examples of this in the worksheet today. So please take a look at those examples. This is called completing the square. It is building a perfect trinomial square when you don't know what c is. Okay? All right, good luck. Reach out if you need support, and I hope you have a great day. Bye.